Apologies, I took a minute over here. All right, gentlemen. So more on the execution layer. So this is about the storage layer, which is the hardware department, guys. And now to the software department, guys, which is called the execution layer. It is called map reduce. The reason is it takes care of the map and the reduce tasks and about the computations that it takes care of, guys. Okay, that's why it's referred as a, or I refer it as the software department. It is responsible for running a job in parallel on many servers. Okay, what is happening is when our code, so let me go here. So what do? We go ahead and write some scripts in high, big scoop and things like that, guys. So let's go ahead and use a different one here. So will go ahead and use that. So you write scripts. When you write scripts, guys, what happens is your tools will generate a jar file, a Java jar file behind the scenes. You give the input in the form of SQL and English like scripting statements, and then they will generate a jar file. Now that jar file will be moved to the blocks of data where your data is sitting. So it will move to the first block and the second block, and not to the replicas. And it will start performing the computation, guys. Okay, and what is happening? Well, they're running in parallel. The computation is happening in parallel in both of the blocks at a time. That is what we mean by they run in parallel. Handles retrying a task. So in other words, if while the computation is going on, and if suddenly this goes ahead and it goes down, right, what will happen is it will go ahead and figure out where the replica of that block is. Okay, and the Hadoop framework will detect that, hey, I have another replica of block A here, and what it will do is it will go ahead and now start running the code here on this replica because that commodity hardware failed. Okay, and the reason we assume that the hardware will fail is because, guys, in Hadoop world, in big data world, we can use what is called commodity hardware. We don't need to use what is called the enterprise class servers like in traditional architectures. Okay, these are cheap servers. The difference between an enterprise class server and a commodity hardware is that the commodity hardware can fail at any time. So that assumption is built into Hadoop that the commodity hardware can fail anytime. So if it fails, it will only take care of rerunning the task on another node. So that is what is called fault tolerance of computation. Not only Hadoop provides us fault tolerance of storage, but it will also provide fault tolerance of computation, guys. From a computation perspective is what it is. Okay, jobs consist of map and reduce operation. What is a map? What is a reduce? We'll see in the coming up ones, guys. Okay, but in map is something where you perform your business logic. Reduce is something where you perform your analytical logic. Is what you can think of, guys. Okay, gentlemen, ladies, okay on this slide, guys. We'll get into more details of this one, but I'm just introducing these things, guys. Okay. Okay, guys. So what does Hadoop do? Hadoop will take your data, it will break it into multiple small pieces. Then what it will do is it is moving the code to the place where the data is sitting. That is what we have seen, guys. Okay. At first it was the data which was there. Then it moves the code from here to here and performs the computation. That is what is called data locality. In other words, data sits where it is there, and code will be moved to these servers where the data is. There could be one laptop here, another developer may be using another laptop here. Okay, you will have multiple developers using multiple laptops, and what are they writing? They're writing different kinds of scripts. As you're writing different kinds of scripts, what is happening? You're generating the code. Your tools will be generating the code, and the code will be, the code is moved from here to the place where your data sits. Similarly here, this code will also move to the data place where your data sits, and computation is getting performed. So that is what we mean by code is moving to the place, guys. Okay, and one more important thing, guys. Okay, in the world of big data, if this is the size of your code, go ahead and say this is the size of your code, the size of your data is in this order. In other words, if you compare these two, your data size is very, very huge compared to the code size. So if you move the data to the place where the code sits, like in traditional architectures, what will happen is the network traffic will be very, very huge. The network traffic will be huge, and the network bandwidth also will be very, very huge, guys. Okay, so what did they do? They intelligently reversed it. They moved the code to the place where the data sits, and then Making sense, guys? Can you give me a quick acknowledgement? Pardon me. Okay, great. Thank you, guys. So move on. So one more time. Hadoop is scalable, guys. What does it mean by scalable? It's a virtual execution and storage layer. So virtually, it is a group of computers which are acting as a single computer, not only for storing your data, but also for performing computations. Okay, so your group of CPUs, all those things are acting like they're one CPU, one RAM, and things like that. It's a sum of all the capacities that you have. That's what we mean by virtual, and it scales linearly with cores and disks, guys. Okay, what does that mean? Well, let's come here. Pardon me. Pardon me. Sorry about that, guys. Okay, so what I have here, guys, each node is a single server. A group of nodes can be called as a rack. A rack is a physical enclosure where you'll have your nodes, guys. We'll see some screenshots in the coming up ones. But for now, node is a server, rack is a group of servers, guys. Okay, and a group of racks is called a cluster. Okay, in a data center, you will have a group of clusters, guys. Okay, and what is that we are saying? We're saying it scales linearly with cores and disks. So in other words, if I'm using only one node and it's taking 10 hours of time, and if I were to go ahead and add about 10 nodes, right, my computation time will decrease by to 1 hour. If you notice, there is a linear ratio. As you're increasing your nodes, what is happening is your processing power is increasing, your processing time is decreasing, guys. Okay, there's a linear ratio in which it will increase and decrease. That is what it means by it is linearly scalable. You add more nodes, you get more processing power, your computation time decreases, guys. Okay, making sense, guys? Okay, guys, and each block is replicated 3 times. If you notice, whenever our file is split, the block is replicated 3 times, guys. Okay, and each task must succeed or the job fails. So later, when we run the map reduce jobs, what will happen is on each of these replicas, okay, first it will run on one replica, and so let's come back here. Let's take a look at this one. Okay, so that is state node 1, node 2, node 3, node 4, node 5, guys. Okay, that's my cluster, and that's my 100 MB file. For sake of simplicity, I go ahead and split it into 64 megabytes into 36 megabytes. Step 1, it will go ahead and put that there. It will go ahead and put that there. Okay, and what is happening? The replication is happening, guys. Okay, so what does that mean? Well, come here, come here, come here. There's your block A is getting replicated there, block A is getting replicated there, and block B is getting replicated there, and block B is getting replicated there. That is what we mean by it is getting replicated 3 times, guys. Okay, each task must succeed or the job fails. Now, when the code runs, guys, let's take this one. Let's take this one. When the computation is getting performed on your block A and block B, if at all this task fails and only this succeeds, right, then your job is not, your program has not completely succeeded. It is in a failed status until it successfully runs this. Okay, that is what we mean by each task must succeed. So all the tasks must succeed. If they error out, then the program is not complete. Okay, we'll talk more about that, but that's a quick way to understand that one, guys. Okay, and why are we calling reliable? If one server goes down, what will happen? The storage is available as a backup on another server, so it is reliable. We are not at a loss of data. And if the server goes down even at the time of computation, the computation will get performed here on another block of data. So this is called